Hello, everyone. Welcome to the next talk from the Quality Gems track at TestCon Europe 2022. This talk is pre-recorded and is from Amir. The talk is called I Don't Need No Tests. Amir is the Senior Vice President of R&D at Parameter X, and he's responsible for building a multi-zone distributed system that detects and mitigates automated attacks on websites in real time. Some serious cybersecurity engineering there. He has led several software engineering groups in the government focusing on cybersecurity products and worked many years as a software engineer and security researcher. He has an extensive experience leading software teams in multiple disciplines such as web apps, IoT, telecom, and machine learning. And today's talk is about shift left. Shift left quality assurance has perks and risks, and he will share with us their story of how they built the engineering group with no QA team from day one and the impact it had on engineering practices, quality procedures, and actually the speed of their deployment. I assume it's a positive impact. I will add the video to the stream, and here it is.
Hi everyone, thank you for joining me today on this session. I love the theme of this event, focusing on tests and quality, such a great concept for a conference. What popped to my mind when I was thinking about what I can share with you all was our journey on quality and how we built our engineering group to push to have better quality and things we learned along the way that hopefully can be of value to you all. My name is Amir. I lead some of our R&D at Human Security. I'm passionate about building things, working with people, and combining the two of them for a great culture of engineering and building things together. So, this is our story, and the story is how we built our engineering group from day one when we started the company without a QA, and the impact it had on engineering practices, DevOps, maintenance, and quality procedures, speed of deployment, everything in between. And that's a lot about culture. Now, like any story, and this is a story, our story, like any story, it has some prequels. For me, it's the marks and memories of previous events at previous places. When I was sitting in meetings, a retrospective, for example, where we were covering a bug that was reported by a customer. And the discussion was around why didn't we find the bug and whose fault was it? And I hate when the discussion goes into whose fault with this. And then the discussion goes into, was it the QA's responsibility? Was it the engineer's responsibility? Perhaps a gap in the PRD that we missed and could have predicted ahead of time. And like I said, I really hate that discussion, and I think it's completely avoidable when you have the correct values and work procedures in place with the right expectations from everyone. So when we went to build our engineering group and culture, we knew that there is going to be no QA and that ownership is not going to be moved around from one team to the other as you build and maintain things. Now, in common terms, it's quite popular to have the phrase, you build it, you run it. I'm sure some of you have heard about it. I do prefer the concept of own versus running because ownership implies more than just creating an end-to-end cycle of how code is shipped and how things are managed. It emphasizes specifically the sense of ownership. And that ownership is required when something breaks in the middle of the night or when a bug is reported by a customer, and how to handle that long stretch of maintenance of a system as it changes over time due to security, scale, bugs, feature requests, everything that comes with a long-standing product that you need to maintain. And when going into the concept of non-QA and ownership, it really implies, and I'm going to talk about it in a bit, the shift left movement of doing more things at earlier steps, and the shift right, or chaos engineering, is another way to look at it, where you maintain things and how do you run them and how you manage them over time after deployment. These two come into play together to create a better quality of products and a culture that comes with it. Now, I assume that this is a very common drawing that many of you have seen in one forum or the other. How do you push something into production? How do you build a feature? You have the design phase, you have the development, the testing, the deployment, and monitoring it over time. And it's whether it's waterfall, Scrum, Agile, you still have a flow of how you push a feature from ideation into production, even if the cycles are very short. And I think this flow of steps has some fundamental problems with it, and putting it in a bit of a different way is, first of all, shifting left the step of testing by putting tests under the same bucket as developing and building, since I don't see any difference between writing tests and developing the feature. The tests are part of the feature. And if you look at the time you spend building something and the time you spend maintaining something, you have to look at the concept of the long stretch of maintenance. Monitoring and fixing is going to be long after you built, tested, and deployed the code. And a lot of the problems are going to come at that stage. Even if you have full test coverage of everything, you're still going to discover issues you haven't planned for at later stages. Now, let's start with the shift left. Shift left quality assurance has some perks, it has some risks. This from my takeaways as we built and scaled the engineering team. The principles of putting more tests into the hands of the engineers means that you need to work with them, train and educate on what is a good test, how do you effectively test your code, what would be the most likely thing to fail, and where to aim at what we're testing. The shift right is more about chaos engineering. How is it going to work in production, where we might find unexpected behaviors, where it can involve, deploying small changes to production and then monitoring closely over time and reacting quickly if things happen and failures occur. And a lot of approaches to how you can do that shift right, from A/B testing, canary deployments, chaos engineering, many ideas in how you can run and manage code over time to make it more with better quality. Now I want to give some examples and where they come into play in our story. Let's start with the first one. We have a feature-rich web application with multiple teams working on it. In that scenario, scoping behaviors that should always work is something that you want to focus on. That will allow us to create internal and live tests that continuously monitor these behaviors that they are working as expected over time, both in the CI/CD phase where we're checking them before deployment, and in the post-deployment over time when we're trying to understand if something that we built still works the way it should have. So that's the first example. Focusing tests on the behavior you want to make sure that work over time. The second example is a bit different. So in this one, we are building an SDK and shipping that to a customer. When we're shipping an SDK to a customer, we have a lot less room for errors. because we cannot roll back. We can't just do a hot fix. It's not on our environment. We're sending it for somebody else to run it on their environment. In that scenario, you want to monitor things like bugs, questions, any kind of issues, and make sure you have rigor tests as part of the development process and a pipeline that always installs and runs the SDK with every common configuration. I would say any possible configuration, but sometimes that's not applicable, but definitely every common configuration. And the last example is one where you have a complex mechanical device that just can't be tested automatically. I had such a scenario in my past, and I'm sorry to say that sometimes you can't automate anything. If there is something that there is no way to automate the test around it, you probably need a manual QA team to check the device and every single device that you're creating. If that's your scenario, then we have less to talk about. But if you're in the area of the first two, then I think the rest of the talk is very relevant. So really, no QA at all. Is it reasonable ask from an engineering team, especially as it grows and scales? And the answer I have is yes. As the team building the services also own them, they will create the most effective automation for testing and deployment. They know what to look for, they know when it will fail, they have learned over time what might be riskier, more risky, less risky, more effective, and that will allow us to have higher speed of development and spending less time coding things that we don't need. Now, a QA expert is something that you might want to bring in. Automation engineers or a QA expert are fine for setting the ground, for kicking off when you may not have the right practices in place. Taking this SDK example that we just covered, that's a very unique scenario. Maybe you don't know how to test it, and you can bring an expert that can help you define the best way to create those kinds of automations and have a quality code being shipped. But it's always better than just bringing people that will manually test a code that you're creating. Now, once those expectations are clear, like I said, the team will add that tests that are needed. They will ensure that things won't break, and they will make sure that when things will break over the lifetime of a feature, things that sometimes are outside of our control, they will know how to fix them the best way. A phrase I often heard was over the years, well, sometimes you do need a QA. Let's bring in some quality assurance employees that will help test something that's not working well. And my usual response to this is, no, we don't. If we get to the place when we are thinking or hearing that this is the solution, it's a good indication that something isn't working right. That could be lack of quality and automated tests. It's also very probable that we have some root cause that we should go and look for in the design, in the process, maybe even the ownership of a team over a certain component. We need to go find the root cause and fix that. So if you hear that sentence, that's a good indication. For us, it was a good indication that there is some root cause that we need to go and look for and fix that, and that's what we did. Now, with that being said, sometimes some things that you build might actually require more rigorous testing and a more stricter process than others. And it's important to remember that not everything is equal. Going back to the example, there is a vast difference between a web application where you're managing most of the code versus an SDK being shipped to customer. Such an area like the SDK does require more rigor and stricter process of automation and validation. So how do you pick what to test? How can we know what's the most effective? You might have sensed that I'm going to talk about TDD as the approach to fix that, and I would say yes and no. I think it's a very good, very, very good technique, and you can use it for a lot of areas in the development process. But like any methodology, if you're taking it as a theological idea and trying to use it for everything, you will write unnecessary code. We will ship code slower. We will just overburden ourselves with unnecessary tests and focus on the wrong things. So I don't think we need to test everything. It's important to test what's really making an impact. If anything, I think the concept of behavior-driven design and how it applies to the scope of quality is a much more accurate methodology. That one focuses on testing the behaviors that we want to ship to customers or the behaviors that we want to make sure are driving the business, and not every piece of code around it. And once you're validating the behaviors that are important, both in the development phase and throughout the lifetime of a feature, if something breaks, whether from a code or something even outside of our environment, we will know that the behavior is not working again and we need to go and look for the problem and fix it. But if it does work, even if we introduce the problem, the impact on the customer doesn't exist. And that's what we really care about. We want to make sure that whatever it is that we are building might have bugs, might have issues, but the customer is getting the value that they ask for. And it doesn't matter if the customer is an external customer paying us or an internal customer that's using a service as an API or something internal. It's still a customer in the sense that they're using something that a team built. So with everything that I've said so far, that it really goes into the sense of setting the right expectations with the engineering team and letting them know what we expect them to do, what's the focus that we're asking from them, and we're doing it both to engineers that we have, but especially with new ones that we're talking about hiring and bringing on board into the team, because those expectations are what they're going to meet when they are building code and working with others. It's a big part of the culture of if you build it, you own it. Now, if I want to go over the concepts that we have here about these expectations and explain why they're so important. So the first one is, if it breaks, you need to fix it. And that's sometimes not very clear to engineering teams. And I'm sure some of you can relate to that if it broke, something that doesn't work anymore, who should fix it? Where is it going? And I'm saying, you build it, you own it. If this is a team that built something and that item broke, they need to fix it. Nobody else should do it. It's their job. Even if it breaks in the middle of the night, they need to wake up and fix it in the middle of the night. And this is also important because that implies that they should have the right metrics and alerts to know when something doesn't work anymore. Now, we've covered the first three. Moving on, we want to make sure that if it breaks, even if they hot fixed it and something is running now, we need to set time to deep dive, to review it later on, and to make sure it doesn't happen again. Set time, priorities, resources, however you want to look at it. It's important to do that, both to show people that we care about quality and we want to make sure that they don't just wake up to fix things, and it does drive better quality of features over time. And the last is it's okay to fail. We just need to make sure that we detect the failures fast and we know how to restore faster. But failures are acceptable. Now, again, this is from our point of view and the products that we're building. And what does it mean to have a failure? Failure is a very broad term. I'm not talking about everything breaking down and what's working. I'm talking about a concept of even a minimal feature that you built stop working. You want to make sure that everything as a whole still operates the same way. Which brings us to the concept of if we fail, let's fail successfully. And that means, again, like I said, teams monitor their own code. They are responsible over time for what they're building and what they're shipping. And think about it. If I'm building a feature and I know I'm going to be the owner of that feature over time, and I know what's the behavior expected of that feature, that will drive better tests, better metrics, better alerts covering that feature because I know it's my responsibility. I'm not passing that responsibility and ownership to anyone else to do that after me. So, and this is as a team, not as individuals. And it's really important to look at it as a team. The team knows that it's their responsibility, not any certain individual. And that brings us to some ideas of how do we know that we failed. It means that looking at things like a test that wasn't applied before deploying the code, let's make sure we're doing it correctly. If a code failed and we immediately saw the errors, we need to fix that before moving on. If the errors were investigated and the root causes were found, then a fix can be deployed. And looking even further, if the fail was in production and it caused a bigger issue than we expected, we want to take that as a lesson to debrief and deep dive and learn so we can find ways to improve the system over time. If we know how to fail successfully, both as a culture and within the system, over time, and then over time doesn't have to be long stretches of time, it can be very quick, rapid improvements, we will have stabler and better products with a great sense of ownership from the teams building those products. Now, once we've set the ground on creating the right tests and metrics and process around delivering code with ownership on the code, we need to look at further into what could be impacting a feature that we built and how are we going to test it properly over time. And this goes into the idea of infrastructure as code and configuration as code. Now, you want to enforce the same practices as much as you can. Obviously, there are differences, but enforce the same practices as much as you can on infrastructure and configurations. Now, what are those good practices on code? It's things like code reviews, proper code branches, continuous integrations, tests, obviously. If it's possible, depending on what you're building, continuous deployment. And once that is working properly, the next batch of bugs will come from different types of changes impacting and touching our code. Often that configuration can come from infrastructure, like I said, but it could be also back office or customer configurations, customer specific items that are being put in place. And if you move to manage these as code with the same notion of review, auditing, rollback, automated test on a configuration being added, and alerts on something that breaks after a configuration was added, that will push the system to be even more stable and at a higher rate of quality. Now, that goes hand in hand with feature flagging and gradual rollout, also in the sense of infrastructure and configuration, not just code. If we're combining all of these three ideas, we have a great combination that can give a lot of confidence and peace of mind when we roll out a change, whatever that change is. A feature, a code, a configuration, something within the scope of the feature. And again, when we have the right metrics and alerts, we can deploy changes and enable them for a certain portion of our usage, validate everything is working properly, and then continue to deploy it for everyone. Now, I've talked a lot about metrics and alerts, and these are critical in the sense of that long stretch of maintenance that comes after deploying a feature. And we need to measure what matters and what makes an impact. We need to convert it to some KPI, and we want to have notifications and alerts if anything moves in the wrong direction. And I want to focus on that, the difference between notifications and alerts. It's quite straightforward. A notification is something we want to know about and we want to address, but it doesn't have to be right now. A notification, it's not necessarily actionable. It just, FYI, this happened again, maybe you want to take a look at it. That's a notification. An alert has to be actionable in some sense. It has to be something that, if I'm seeing it, I need to do something now. I'll give a concrete example. Say we have a system that is in a very high usage and auto scales. And sometimes the auto scale can take a few seconds here and there, and we have some automatic remediation around it. If the system sends us a notification starting the auto scale, stopping the auto scale, we can look at it and decide if it's something interesting that we can learn and maybe improve, seeing how many notifications we're getting, at what times of day, and on what services. There is no point in making these alerts because if the system is automatically increasing and remediating whatever happened, we don't have any action to do. The alert will come if a process started and doesn't end within a certain amount of time. So say the auto scale should take 2 minutes and 3 minutes in, we still have a capacity issue. That's the moment to send the alert because this is an actionable item for the team to go and understand why is the auto scaling not working for whatever reason. Now, looking at metrics that we should look at, we have the standard operational metrics, everything such as RAM, CPU, cost, all of those. And we also have product specific, which can be anything from time on page, users per day, conversions. And we do want to make sure we're focusing on metrics that should be connected to the system we're building. Say number of users might be impacted more by marketing campaigns than features that we're building, but we still want to be able to monitor that and look at the trends happening there. But other things could be very tightly coupled into features that we're building and potential bugs that were introduced throughout the process. Having those metrics and alerts in place is also the best indicator that something outside of our control changed, because those metrics, especially the product-specific metrics, are agnostic to the features that we're building. And when you're putting metrics and alerts, you don't want to just look at the feature that you created. Same with TDD. Don't just test the code that you wrote. Go into the behaviors. Put metrics and alerts on the behaviors that you care about within your product, within your system. So both on the tasks and on the metrics that you're looking at over time and you want to make sure are operating appropriately. Now, the dark side of this is we just talked about putting more and more cognitive stress, pressure, requirements on our engineering team. And at a certain point, this can break. And we want to be aware of burnout and remember that happiness matters. We care about the happiness of our engineers, of our members within the team, and we want to make sure they're motivated and they are enjoying what they're doing. And like I said, alerts versus notification is definitely a place to watch out for and can create unhappiness if every notification is treated as an alert. But beyond that, we want to take those items such as alerts and track them as a separate KPI. And look at those. It's crucial to track them in terms of off hours, work hours, weekends, and make sure we address them and fix them over time so that the team won't wake up and continuously work and get interrupted. And it's not necessarily if it's after hours, it could also be within work hours. But again, if you have constant interruptions throughout the day, it really hurts your ability both to be productive and that sense of flow. If you don't get flow within the day to work, it really hurts your commitment to what you're doing and your ability to create quality code. Now the burnout metrics, going back to it again, because I really want to stress this is very important if you're going to the path of shift left and shift right and putting the ownership on the team building things and owning them. We want to look at those potential burnout metrics, and those are especially things that interrupt their day-to-day. So you can see a graph as an example of here of how we're looking at it and how we're tracking that in management meetings. We want to see what's happening here. What is that spike of alerts at a certain day or a certain week? We want to ask what happened. Is it recurring? Was it remediated? Do we need to change something in the system or process or anything due to that? Sometimes the answer is it was fixed. Sometimes the answer is it's a new alert we introduced and we need to tune it down. And that goes into, well, maybe we need to change the process of adding an alert. If alerts can create noise and interruptions over time, maybe the right way is to create some rollout process around alerts to make sure they don't create a lot of noise and interruption and either make people just ignore them. You know, you see the Ops Genie alert, click a button and move on, or continuously wake up and look at it and have nothing to do. So it's also really important to track those burnout alerts, and validate that the time is given to fix crucial issues. Going back to those expectations, this is exactly that representation of the expectations. If it breaks, you will have time to make sure it doesn't happen again and you will not be interrupted again. Now, this is a journey, and we've been running our journey for over 6 years now. And if you're going to try this path, I assure you that you'll have a different story to tell than we had and I'm doing today. Something that was very important for our process of learning and improving was introducing the process of debriefing and learning from issues, learning from incidents, and incorporating those learnings back into how we create code, how we create the system, and how we assure quality over time. It's something that really helped us and put ownership in the right place and look at every potential issues with a notion of no blame, let's be calm, let's analyze it, let's focus on takeaways and what do we need to change in the process or the technology so it won't happen again and the system will be better and better over time and be much more efficient and with less errors and less bugs and less interruptions. It's really important to remember that. We had a unique opportunity. Starting fresh, like when you create a new service in the company, it's always an opportunity to take all the learnings that we had and say, let's build it in a better way than the code we built last year or the code we built 2 years ago. And starting a company really is a great opportunity to put a new paradigm into it and force everything to be around that concept. But I'm going to assume that for many of you listening now, it's not the case. You're not in a vacuum. There is already some steady state, might be very close to this, might be much better than this, and maybe we're very far away from this on the notion of I'm building the code, somebody else is going to test it, somebody else is going to run it over time. If you want to try and move away from that paradigm into the one of you build it, you own it, you need to start small. You can't just change everything and do that switch. You need to break it down and look at the two directions, the shift left and the shift right. I'm going to start with the shift left. It's something that I think is much simpler. The way to start with that shift left approach of moving tests to be done as part of the development phase without a separate QA team is by giving the engineers more and more responsibility on building the tests, and over time reducing what you're asking those QA engineers to do, telling them they're not expected to test, they're expected to write code that will test, they're expected to create automation, but never run manual tests. And every time you see them creating a document of these are the tests that we're going to do, and then we're just going to run them one by one, that's your opportunity to say, no, stop. That's a great PRD, what you just did. Let's write it as a code. And if you don't have that set of capabilities within the QA team, bring in the engineering team, put them together, tell them you're going to write this together and create a test doing the steps written here. So it's going to be part of the code and not a separate phase run by someone else and manually. The shift right takes more time, and it's much harder because in that area you're actually telling employees you will be the one owning this service over time when it's running in production. And you might have technological gaps to even start doing that. You might not have the right metrics or the right tools to monitor and notify the right person. So there is no easy way to do that. Again, going back to step by step, a movement in that direction can be when you're building a new feature or taking some smaller feature and starting with even existing features that might have a lot of issues, bring in the team that built them and tell them, this is now your shared responsibility. This process, this service is creating a lot of issues, a lot of noise. You're going to take the ownership of making sure it's running continuously in a healthy way over time, and in that way start to move the needle in the direction that you're aiming for. Now, it's not for everyone, and I've seen engineers become much more capable and with a lot bigger sense of ownership and more professional and with a better understanding of the problem and the scope of the software they're shipping and thinking about maintainability for the longer terms when working in that environment. But this is not for everyone, and that's okay. Sometimes you have engineers that want to just code and don't want to manage the code after it's deployed, and they don't want to test it maybe. And if you're going to force people to work that way when it's not something that they want, both sides will be disappointed. Now, I'm not saying that you should accept that and let one team work in one way and the other work in another way, or even within the same team have some engineers with more ownership and some engineers with less. I think that if this is the way you want to operate, you want to put that up front. You want to have that as a very clear set of expectation of what does an engineer do in our team, in our group, in our company, and tell them that ahead of time. If that's something that they want, great. You're going to have a great journey together. If it's something they don't want, that's okay. There are probably other places that work in a different way, and you should stick to your culture. Now, I have to say again, when I've seen engineers work within the culture of you build it, you own it, they are much more professional and know how to manage the code in a much better way. I'd love to hear your thoughts about this subject. Feel free to reach out, tell me what you think, what you want to do. If you want to try and you want to get some tips on how it's working and best practices that I might have not been able to cover in just 40 minutes, I'm more than happy to share my thoughts with you and hear about your journey. Thank you for listening and have a great rest of the conference.